Hey, Sam here. Let's do another Leetcode question together. We'll choose an easy algorithms one at random and see what we get. Number two, I've already done this one. Let's try again. Number 1700, number of students unable to eat lunch. All right, let's start. Well, hopefully all the students could eat lunch, but we'll try our best. The school cafeteria offers circular and square sandwiches at lunch break, referred by numbers 0 and 1 respectively. Let's pull me down over here. All students stand in a queue, and they either prefer one or the other. So which ones do we want? There's exactly the same number of students as sandwiches. The sandwiches are placed in a stack, so we're using a stack, it sounds like. If the students at the front of the queue prefer the sandwich on top, they'll take it and leave the queue. Otherwise, they'll leave it and go back to the head of the queue. Wow, these students are good students. This continues until none of the queue students want to take the top sandwich and are thus unable to eat. You're given two integer arrays, students and sandwiches. Sandwich is I. It's the type of the ith sandwich in the stack. I is at the stop, and students is j is the preference of the jth student in the initial queue. Okay. Return the number of students that are unable to eat. So that's all we care about. So for example, there's 4 students. The first 2 prefer sandwich type 1, and there are sandwiches 0, 1, 0, 1. First student does not take the first sandwich, so it goes to the end of the line. Circular array. Second student takes a sandwich. No, it does not. It leaves the top sandwich, goes to the end. And then the third student takes a sandwich. Fourth student takes a sandwich. Fifth takes a sandwich. Sixth. Yeah, okay. So all students were able to eat. Okay, this is kind of cool. Basically, we don't really need to do this circular array, I don't think, because we know eventually however many digits there are of each sandwich, all the students will eat. So is that true? So here there are 4 1s, but there's only 3 1s, and there's only 2 0s and 3 zeros. So there's one student that wants a 1 that can't have it, and one student that wants, I would have thought there's only one student that couldn't have the sandwich. So, but that's not the case, because what happens is these first student's fine, second 2 go to the end of the queue, then these 2 are eaten, and then there's another 0, but because all of them are 1s at this point, they can't eat this 0th sandwich. Okay, that kind of makes sense. So let's just look at that again. 1 1 0 0 1 1 0 0 0 1 1 sandwiches, students. So initially, the first student takes a sandwich to one student. So we remove the first from both, no problem. Now here, these 2 students go to back, and so these 2 students have gone to the back of the line because there's a 0 sandwich at the front and they can't eat it. Now 2 students take sandwiches, and so these 2 sandwiches get 8. Great. And now we're stuck at all students wanting a 1, but because there's a 0 sandwich next, there's nothing they can do. They can't get to these sandwiches because there's a 0 at the front, so we have 3 left. And this may be very basic, and you guys may understand this already, but it's good to be clear about what's going on, because I think we might be able to find some sort of trick here that lets us calculate the number without having to keep this circular array. Because let's just think about it. So approach 1, brute force is check head of students sandwich. All right, while possible, while true, this might be an infinite loop. Match, if yes, pop both. Otherwise, circular shift student array. And if circ shift count is n for n students, break from the loop, return length of array. And we'll basically have some sort of thing counting this, and we'll go into the specifics of that. This is, let's think about what this will be. No matter what, the while true will be at least O of n for every single student sandwich. Checking the heads is just O of 1. so that's fine. Popping is actually O of n for lists, so we might be able to use a different data structure here to make it for O of 1. And then circular shifting the array is O of n for list. This could be with a different data structure O of 1 as well. And then if the count is equal to n, we break, that's O of 1, return the length of array is O of 1. So in the most basic case, this becomes a O of n squared type time. We're using the existing arrays. Let's assume we're allowed to modify them in place, so it'd be kind of O1 with in place space. I'd like to see if we can do a little better than that. With some optimizations, we might be able to bring brute force to O of n with diff data structures. So that's one way we could try to fix that, but I'd like to see if we can do something along the lines of keeping track of how many O's in a row there are, for example, or ones in a row, and inside the sandwiches, and see if there is a different count of students for that. Because here the problem for the students is there's 3 zeros in a row and there's only 2 O's, so we're going to fail after the second O. Actually, yeah. So let's just say the way we could kind of do this is we count the number of ones and zeros students, and then we can remove ones and zeros up to that point starting from the left. So we can remove as many ones as we want initially, then we can remove as many zeros as we want initially, and we keep going along that. And once we're done with that, so let's just think of that second approach. Count ones and O's of students. That's O of n. Then iterate through sandwiches up to O's count. And then whatever is left, we return the length of array minus the count as our final answer. Because here, for example, with this one, we know there's 4 so let's just do the logic right here to explain it. So we have 4 ones and 2 zeros. So we can call that, like ones equals 4 and zeros equals 2. Let's do it that way. That's a little bit cleaner to understand. So now in the sandwich list, we can iterate through the list and subtract from these values as we go. So we have 1, 1. Let's say our pointer is here. We can subtract 1 from the ones. And now ones equals 3 and zeros still equals 2. Then we go to the next step. Everyone can still see this? Good. Then we go to the next pointer and we see, so let's actually just call this our index equals 0, and now our index will be equal to 1. And here we can subtract a 0. So now our ones is equal to 3, 0 is equal to 1. We'll do it again for the next pointer. Index is 2. We subtract from zeros because we can, so now zeros is at 0. And we are continuing. So far so good. And finally we've reached the next index. Index equals 3. Can't do zeros minus 1 because our zeros is equal to 0. So we break here. So we break. And now we know that there is at index 3 through the length of the array. So the length of this array is 6. And we want to return our length of the array minus the index. So that equals 6 minus 3 equals 3. That should be our answer. And that is correct there. Would that apply to this case here as well? Let's see, there's 2 ones and 2 zeros. We can remove 1 from each as we go through the array, and we get to 0 at the end. So length of the array will be 6. The index will also be 6. So we get 0. Yeah, okay, I like that. And the reason that's nice is because now we don't need to keep any sort of stack. We're just iterating through the list and we're subtracting from 2 values, so we get a solution that's O of n time, and O of 1 space. And I think that's going to be as good as you can get. You can't go better than O of n when you're going through this list of students and sandwiches. All right, so let's build up this array. We'll do, let's say, actually the sum of students is going to be 1s, and 0s equals length of students. Let's actually n equals length of students, and then 0s will be the opposite of that. Because if they were all 1s, then there'd be 0 zeros, and vice versa. And so now we go through the sandwiches. So for sandwich and sandwiches, and we'll do enumerate. Is this the right way to do it? Let's actually, yeah, that's fine. Okay, so if sandwich equals 0, and what I'd like to do here is kind of do a check for, sorry, froze for a second. Okay, so if the sandwich is 0, then we want to check if zeros is greater than 0, which we can just do by if zeros, but we'll make it clear like that. Then we can do zeros minus 1, and we continue, else we break. And similarly, else if the sandwich is a 1, if 1s is greater than 0, 1s minus 1, and else we break. So let's clean this up. I don't like this very much, and at the very end I'd like to use this index as well. So we return the length of students, or n minus index at the very end. We could probably do a little better than this. I think for index in range, n plus 1, or no, n is correct, and then we can say sandwiches 0 or of index, and that way we're actually using, well, that's the same thing, because this creates it and we can still use it at the end. So here, if not zeros, break, and then otherwise we just do that. So that's maybe a little cleaner, and then we can do the same thing for 1s. And here we don't even need the else, because that's, well, no, we do. Okay, I think that's about it. So let's think about whether or not there's any optimizations here. I want to make sure this will actually run. So let's say we're given our 4 and 4 here. We're counting through each sandwich, checking if it's equal to 0. And that way we don't have to compare it to the students list anymore. And if we've got a 0 sandwich and there's no more zeros left, we're done. Technically we could just return n minus index at that point. That might be the better way to do it. And then otherwise, if it's an empty, why don't we just return 0 because we got to the end. Okay, let's try testing this actually. I think that's fine. I'd like to see how this does. Oop, runtime error. Got to spell sandwiches correctly. Here it looks like we spell it like that, so let's try that. Oh, I added an H, sorry about that. All right, testing, and let's see how we do. It passed the test cases here, so I'm happy about that. Let's quickly think about the empty. If there's an empty array, then 0 is still true. There's no students to go out. We're assuming certain things, for example, that the input arrays are valid. It looks like they guarantee that for us, and there are no invalid entries. They all fit in memory, so no worries there. This is classic Leetcode. Let's try submitting it and see what we get. All right, come on, come on. Yeah, passed. Awesome. I'm really happy to see that. It looks like it's well within the bell curve. Oop, let me pull myself back small again. And I'm trying to think about any other optimizations here. We're all within a couple of milliseconds, so this is mostly the back end. I wouldn't really stress about this too much. Fun little problem. It's good to think about this little optimization here. because you don't have to do any sort of circular shifting. You don't have to deal with all of that mess, which is a real big mess. Anyway, I hope that was interesting to everyone watching, and I'll see you all next time. Cheers.